Okay, in these kind of problems, we really need to do a little bit of investigating before we work at them. We have to remember that the standard form is ax squared plus bx plus c. Okay, so when we're looking at these particular equations, we want to focus in, we always focus in on the c value. And whenever the c value is a perfect square, we have two particular options. We can look to see if it's a difference of squares or if it's a perfect binomial square. The next thing we want to look at to see if it's difference of squares is this value here. So this is a positive, or the sign rather, it's not a value, it's a sign. It's a positive sign, so it can't be the difference of squares. And we also know the difference of squares would not have a center term either, or this linear term. So we can conclude at this point it's not going to be a difference of squares. So now we need to see if it's going to be a perfect square. Now we have to also recognize that when we factor, we're going to have this center term, this linear term here, is generated from multiplying these two terms together and combining them with multiplying these two terms together. So if this term is the same as this term, then it would be twice the square root of c. So let's just work through this and we'll be able to see that a little bit better. Okay, so we know that this part of our factor here comes from our x squared. And the only way to make an x squared is to put an x. Okay, so we have our x and we have our x. And we also know that in this spot and that spot, we have to be able to create a 25. Now the only factors of 25 are 1 and 25 and 5 and 5. And because it's the same sign, it's a positive, so we're going to have the same sign, therefore the two numbers have to add up to be negative 10. Well, 1 and 25 don't add up to be negative 10, but 5 and 5 do. So we know we can put a 5 there and a 5 here. We also know that the signs have to be the same because this is a positive, and they have to be the same according to the sign of the center term. So these have to be negative. Now I have a whole bunch of scribbling here, so I'm going to rewrite it all in red. So we have x minus 5 times x minus 5. Now when you recognize, you can easily recognize these particular equations if by looking first at your c term, take the square root of c term, and your b term must be equal to 2 times that c term. Okay, so if we look at this, we'll notice that c is 25. The square root of c is actually equal to 5 in this particular problem. And the b term, actually we should say the absolute value of the b term, has to be equal to 2 times the square root of c. Well, the square root of c is 5, so the absolute value of b has to be equal to 10. Well, certainly indeed it is, because our b term is negative 10. And so because that is true, we don't have to do all of the rest of the work that we just did. We simply have to create our terms as being x to get the x squared. We have the two x's. And the other part of our term has to be a negative 5 because we need the b, which is going to be basically coming from the square root of 25. Our b term is negative 10, but we only need half of that, so we're going to put our negative 5 and our negative 5. So let's do number 17, and maybe that will solidify this whole discussion. So as we're looking at number 17, the first thing we need to focus on is our c, which is 9. It's a perfect square, and the square root of 9 equals 3. So now that we know the square root of c is 3, we need to take that and multiply it by 2, and we get 6, and we're going to check to make sure that the b term, the absolute value of the b term, is indeed 6, and yes it is. Therefore, we can quickly write our solution, or our factors, as x minus 3 times x minus 3. And let's go ahead and distribute very quickly to verify that. So x times x is x squared. X times negative 3 is negative 3x. Negative 3 times x is negative 3x. And negative 3 times negative 3 is positive 9. When we combine these two terms, we get x squared minus 6x plus 9. So indeed, we have the right factors. So you try number 19 and then resume the video and see if you got it right. Okay, so on number 19, I'm just going to provide you the solution and you can check your answer. All right, so there's the answer to number 19. I hope you got it. Thank you.